Thanks so much, guys. It's great to be here, and it's a great honor to speak at Ray Summit. We are Lepton AI, who is basically aiming to provide launch-ready AI models for you guys to build applications as easy as possible with AI capabilities. We've got a bunch of open source contributions from our co-founders and founding members in the community. And if you heard about PyTorch, Caffe, TensorFlow, Onyx, Jupyter Labs, Kubernetes, etcd, we might have created or contributed to those kind of libraries. First of all, let's address the problem, the elephant in the room, which is like, isn't APIs enough for AI already, right? You import OpenAI, and it seems to be that everything is really great, it's just like one chat away. I'm not going to be answering this question directly, but I'll just show you some data. If we take a look at the statistics, we were really proud a few years ago when we were basically doing PyTorch, and it was one of the fastest growing open source projects. If you look at the start history, which isn't a good metric, but maybe one of the best metrics, you can see that there are a lot of open source projects that are related to models, applications, and things like that have been growing in some way slightly or much faster than PyTorch. Hugging Face has been one of the examples, and Hugging Face right now has tons of models. And recently, Facebook or Meta open sourced Llama, which allows people to basically have an open source chat capability and also code generation, things like that. And if you look at the start histories, it's growing really fast. The fact that people care a lot about domain-specific models, customization with these models, being able to access those models and use those models in an open source way, and being able to apply to their own fields, whether it be multimodal applications or they need enterprise-level security or basically having to ship those models on the edge and things like that, there's really a market or a need beyond APIs to ship their own models, launch their own models, and optimize on top of that. So if you think about it, if that one isn't really convincing enough, let me show you one thing. Imagine you're a CFO and you're in an earnings call. One of our founding members, Yuzi, who was sitting back there, basically made a cute demo showing the difference between a open source API model, which is ChatGPT, and the fine-tuned model that we did based on top of Llama. And we basically fed Apple's earnings call to train that model, and we basically give the model a lot of the earnings call results from the earlier CFOs, and basically we ask the model to then behave as if it were a CFO, and this is the result that we're getting, which is kind of cute. We basically ask the bot to answer the potential for the growth in the number of Apple devices per iPhone, things like that. ChatGPT gave a kind of reasonable kind of answer, but if you look at the model that's basically fine-tuned, it kind of really looks like a CFO, right? Customized models actually go a long way to give you much higher quality and also kind of domain-specific kind of behaviors. You can kind of imagine that a CFO would be basically saying, we're really happy, and that's a great question, and those kind of little words in a company Q&A kind of session. If you're thinking about applications such as industry and things like that, these kind of models, fine-tuned on your own data and your own applications, could go quite a long way. And that's why there's quite a lot of need for model customizations and things like that. Now, the tricky thing is that shipping those kind of models is kind of tricky, right? If you think about it, over the last 10 or maybe 15 years, we've gone through a lot of trouble trying to get familiar with the software and hardware stacks. We kind of started with NVIDIA CUDA and things like that. We've gone through multiple rounds of AI frameworks and things like that. And even today, we're still hearing a lot of new and interesting, but sometimes hard to learn kind of abstractions. We probably heard about TensorRT. TensorRT has a new version called TRT LLM. You might have heard about a new language called Mojo coming up and things like that. They're all great. But what if I were a data scientist? What if I just want to run those kind of models? And I don't really want to go through 5 years of PhD or undergrad study to be able to start getting my hands onto those models. What is wrong with the AI software stack? Right? If you look at the history of computing, you kind of feel that there's a lot of applications that are actually not as difficult as AI. If you think about it, databases, there's a SQL, and you don't need to, if you use the database, you never worry about the underlying, the machines and things like that, whether the load is working well or things like that. You write a SQL, which is a very nicely abstracted language, and it works. If you want to build a web app, it's kind of easy because you basically write a program in Python, JavaScript, NPM, or whatever kind of language is like, and that your mindset is it runs inside one machine. a simple machine, right, a CPU machine, and then you give it to a platform like Vercel or some other websites that host those pages, and then you run happy as a clam. You don't need to worry about the scaling and things like that because abstraction is easy. AI today is kind of tricky because I don't really know how to call it. Like, you basically have to go onto Hugging Face. Sometimes the model works, sometimes the model doesn't work. Sometimes you need to download models from GitHub. They have a Jupyter notebook that runs things, and it tells you explicitly in that Jupyter notebook, if this doesn't work, try those other approaches, try and uninstall that model, that dependency, and then pull it up again and see if it works. Those kind of things are kind of tricky. And this is basically exactly what we have been trying to address. There is a big market. Supply and demand is pretty big. Right now, if you look at Hugging Face, there are something like 6K models last year. And this year, I checked yesterday, there are about 300. Well, actually, I think I was actually like 10 times smaller. Last year, there was about 60K. Sorry about that. And this year, when I checked yesterday, there was about 334K models up there. A huge amount of models, and the demand is also kind of like pretty big in the sense that not only AI engineers, there are also kind of a lot of like data scientists, application builders, and folks who want to get access to those models. GPT models is one prominent example of why different kind of people without AI backgrounds want to get access to those models, right? Right. So we kind of wanted to basically like write an open source library that helps people to get access to those models. And some of our key design parameters, what kind of things we want to have in this library. We kind of used our experiences back in our days when we were AI developers to design the guiding principles. One, right now, Python is probably the de facto standard for all those AI models and model building and application building, right? So it has to be Pythonic. We don't really want it to be like too difficult. And it has to be user-friendly in the sense that we don't really want people to go through all those kind of AI software stack to be able to run a single model. It should be as easy as running the simple Python function. It has to be flexible in the sense that like it doesn't only run in a Jupyter notebook. It has to be seamlessly converted into a web service so that on the other side, if there are JavaScript engineers, there are web application builders who want to use those models, they can use it as if it were a standard open API call. The last one might be a little bit controversial. I think we don't really want Docker. Today, there's a lot of platforms that are built on Docker, and we actually use Docker under the hood as well. But there's one caveat. We don't really want users to directly interface with Docker, right? I'm kind of wondering if you don't mind doing a show of hands, how many people have deployed or run AI algorithms like in PyTorch? Not too many, or a few. How many of you have built Docker containers before? That's a good amount. How many of you have run AI algorithms and at the same time built Docker with that? And for those of you who have done those kind of things, how much you like the experience? I'm expecting the answer to the last question to be no, because Docker is great for infrastructure builders, right? If I want to basically ship some module or ship some kind of software like a database or like big data and things like that, it's great. For AI, I was like, I've been using Python for such a long time, and in fact, the reason we kind of went from the first generation AI frameworks like Caffe, Theano, Torch to today's PyTorch is really because we love Python, right? We want to stay in the Python environment, and why don't we just run things in Python? That's our guiding principle. And we recently, actually, as of 2 weeks ago, we open sourced a library called Lepton AI SDK by designing a key abstraction term called Photon as a standard abstraction to build AI applications. We can do some code later. And then the basic idea is that you just need to basically specify what kind of things you want to run, and then we pull up a model for you in a Pythonic environment. On the other side, you could use Python, or you could also use like JavaScript and things like that to call into it. Now, I've been bullshitting for quite some time. It's about 10 minutes. And one thing I like about the Ray conference is that there's so many people showing code. Trust me, I've been in China for the last 4 years, and I don't see too much people showing code, and I love showing code in a developer conference. So forgive me, I want to basically show you some code that could basically give you a quick idea about what Lepton, Photon, and things look like, right? Okay, so it's light coding. If something goes down, I apologize in advance. Essentially, we basically just want to import stuff. Let's first of all pull up a GPT-2 model on my local box. Right? Now, the reason I don't really do Llama and things like that is that my poor laptop doesn't really have enough memory. GPT-2 is good enough. So usually what we would do is after you install Lepton, you can basically say Lepton Photon run. You give it a model type called Hugging Face GPT-2, and then it should run a local service that allows you to access it. Now, since we're in a notebook, we basically want to also continue running the block. So I just launch it in a subprocess, which is the equivalent of running things in a console. Right? So basically what it does is it creates a Python class that downloads the models from Hugging Face, where it's cached, so hopefully it's fast, and then it basically launches a service. It's a standard OpenAPI service, so that if you want to basically use your favorite OpenAPI client in NPM or things like that, there are links and stuff like that, you can do it. Now, of course, in this case, we also provide a client that allows you to run those kind of things as if you're just calling local functions. Right? So we create a client, and we basically ask it, what kind of methods, what kind of Pythonic methods does this server expose? So we basically connect to it, and it tells us that there is a run function. Now, when you use web services, there's one thing is you always need to basically look at documentations and things like that. So we embed this documentation for you. There is a method called run, and we can basically say, hey, let me know what kind of parameters this run accepts, right? So basically help client.run, it automatically generates the input in a Pythonic fashion. It basically says it runs something. The input schema is it requires you to input these kind of things, kind of similar to a standard, input set you need to do for LLMs. And it gives you an example input, basically saying I enjoy walking with my cute dog and things like that. Now with that, hopefully you will be able to construct a function that actually calls that thing. So let's say result equals to client.run, and I'll just give it a prompt, right? Everything is in Python, and it gives you a string, which is the result. Let's ignore this red thing, it's the internal log, and then basically it says, it returns I love walking with my dog, and he's really liked us for about 5 months, blah, 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 blah. GPT-2 isn't really a good model, but it shows you the basic idea about how to actually launch that model, right? We'll shut this off and basically say, go to the next steps. Imagine you're a model producer. You're have a bunch of Python code. Now, one of the common challenge that we often face is how to make it accessible to my colleagues, right? We usually, what we do is, well, yeah, here's a IPython notebook, just run that notebook. But often on the other side, my colleague is trying to build some applications and things like that, and he was like, well, could you give me an API, right? So in this case, let me show you a simple example being able to do that. I don't really want to show too complex code, so I basically wrote up a simple example about Mandelbrot, kind of like generating a Mandelbrot image, right? It's a simple Python example. You basically say, we write a class, we write all those kind of things as if they are standard Python classes. You can basically define a function that returns a string. You can define a generate function, which is also a Python function. It accepts a bunch of parameters and things like that, and it runs a bunch of torch computations, and then it returns a torch tensor. Now, we want to basically be compatible with both Python and also JavaScript, so basically we convert that torch tensor to a list, but simple as that. So that's basically just a Python class, right? We're also kind of basically define a helper function to show the images. Let's show this one. And now we are at the debugging phase. When you're debugging, you don't really want to debug a web service, right? You want to basically run things in Python and use all those PDB and things like that to do it. That class can be instantiated as an instance, and then you can basically use standard Python methods to call it and get the results, in this case, an image. So we run it, and it shows you that image. Looks pretty good. If there were bugs and things like that, standard Python exceptions pop up, allowing you to change the code and things like that. Now you're like, well, now I can basically run it as a service, a local service, in a separate process. Not in this process, a separate process. We can save the above code in the .py file. I just did it offline. And we can basically say Python listing.py. What happens is that code, eventually the Photon wrapper would allow you to convert that Python class, the instantiation of that Python class, into a web service. That service will expose two functions. One is alive, as we just designed, and another function that's called generate. You can then basically use the same client to basically call it as if See, exactly the same Pythonic code, and it still runs. Under the hood, what happens is basically it is using HTTP to talk to the server and then get results back. Now, that's the result, exactly the same, and things like that. Now, you might ask us, like Yanshin, this is bullshit because I'm on the same machine. Why do I need to have it in a separate process, right? If you think about it, a lot of the AI applications today is like hugely fractured in the sense that it requires different dependencies and things like that. And it's really hard for you to put two models in one environment with different dependencies and things like that, right? Now, if you're able to basically just convert a model into a service, you can basically say, I have my Conda environment that has like PyTorch this version and TensorFlow that version and things like that. I'll just run it. And the other side is like, I don't need to install anything. I just want to call it with NumPy or things like that. It gives you a very clean separation of environments so that launching and stuff like that gets much easier. Now, for example, if I launch like a separate Python process here, right, I can basically just like say, I call this function, and it gives you exactly the same results. It gives you a good separation between the service side and the client side. You can then basically launch these kind of things on the cloud, and we have a serverless platform allowing you to do that. Let me terminate that. And you can basically say you run this Photon remotely. It automatically uploads this into the server, and it runs this stuff. Now, under the hood, we use container technology and stuff like that. But when you're compiling that thing, well, one simple way is basically saying we will compile that simple function, that simple Python file, which is about like 4 kilobytes, into a Docker container. But that's an overkill, right? Why would I want to wrap a 20 gigabyte Docker container just to ship one 4 kilobyte file? Instead, we use Cloud Pickle and things like that to basically pickle the absolute necessities and then ship it to the cloud so that you just need to run it and then you get the results out exactly as we had before. It's a remote, so it takes a bit of time, but usually, if you're running, really heavy computations and things like that, the 10 to 20 milliseconds of overhead doesn't really hurt too much. You can basically run other kind of interesting models, such as stable diffusion and things like that. And the good thing is now I don't really have a local machine, right? I have the Lepton SDK. It pre-ships with an SDXL model, but then I want to run it remotely. And the good thing is I don't really need a GPU locally, but I can still call those kind of services remote as if I'm just running things locally. So if I want to debug my image generation pipelines and things like that, I have a remote GPU for me to naturally use. Now, for the sake of time, because pulling up GPUs is a little bit slower, I already have one service running called SDXL, and then I can basically connect to my service, kind of similar to what I did before, and I will be able to just call it. It takes some time, about 5 seconds or so to do so, and then we will be able to get the results back and show the results and things like that. While we wait for the results to come back, I'll basically tell you one thing. If you are seeing like Llama 2 models, other kind of so in Japanese there's a model called Elisa, and in Chinese there's a model called Baitran and things like that. Pulling up those models is as easy as basically just changing that string, that Hugging Face string, and basically say, hey, I want to pull up that model. You will need to have, if you're running things locally, you will need to have a beefy GPU to do so, but it's as simple as that. That result is ready, coming back, and if you plot it, it looks reasonably good. The idea is that you'll be able to just launch a bunch of AI models and things like that in a kind of Pythonic way, but still enjoying the flexibility of using remote GPUs and stuff like that. This is basically what we kind of do, a quick preview about what kind of things we have, right? And then on top of that, we have quite a lot of things that we could optimize for. For example, we can pull up really fast stable diffusion models. We can pull up really fast Llama models and things like that. For the sake of time, I'm probably not going to be jumping into details about that. But there's quite a lot of optimization tricks that's needed in running today's models. If you run Llama models, for example, you will need things like dynamic batching, page attention, and things like that. There are awesome libraries such as VLLM for you to do so. Right. We kind of integrate all these kind of things into our service so that you can basically find something up to 90 times speed up when you're running typical models such as Llama 2 and things like that. There are a lot of future work that we could do with which is to make it more faster, more concurrent, more scale, and things like that. But that's a story for another day. Now, coming to the question, the elephant in the room. Managing infra is tricky, right? That's why you see quite a lot of interesting projects coming up in the infrastructure space. And the reason we were basically exploring together with Ray is that we want to give people a lot of flexibility in managing resources and still enjoying the simpleness of launching models, running AI, and stuff like that. Ray is pretty great in that sense. And let me show you, well, before I show you the actual code, let me kind of give you a basic idea. In Python, in Lepton SDK, you will be able to basically pull up models such as Llama models and things like that in a local Pythonic environment. Now, Ray gives you a declaration, or basically Ray gives you a way to basically wrap that model, into either a remote run or remote service. Right? And then basically, in that way, all those kind of infrastructure pieces, how to actually manage that cluster, how to actually manage the number of replicas in the service and things like that, gets very nicely separated. As an application developer, we'll be able to just simply focus on our applications. And as infrastructure, Ray takes care of a lot of these kind of things. I'm going to be using the Anyscale's platform to show you how we do that. So basically, install something. There was a tiny bug that requires us to pin Python-centric to 1.10. Let's do that, and then we'll basically initialize Ray, or basically import Ray as normal, right? Now, a minimal example. What if we just like want to write a very, very simple Photon, right? You basically have a class, that's a Photon class in Lepton, and then you basically say, I want to basically decorate this class using Ray remote. And it becomes a class that you can run. It becomes a Ray remote object, that actor that you can run in the Ray cluster. When you run things, everything gets very nicely connected. You get the result as you'll be expecting. Right? Now, let's say we want to run something more complex. In this case, let me show you something that's a common model used in AI, which is called CLIP. It embeds images and video and text at the same time. So now, usually, you write a Python class, right? The interesting thing about this class is we'll be able to expose multiple methods, multiple endpoints. So in this case, let me scroll down the useless code, and what it does is it embeds, it gives you a function called embed, a function called embed text, a function called embed image, and it's basically a long class that does these kind of things in Python, right? Now we call that thing, and then we instantiate two things. One is basically we can run things locally by basically saying we instantiate that clip class. Or we can basically say we use Ray remote to decorate it. It becomes a remote actor. And then we can run these two things at the same time and compare the results. Ray is going to be doing scheduling and things like that to run things at the background. And is the cluster dead? Yeah, it works. So if you compare the results, numerical results, they are about the same, right? You know that they are running things in two different environments, mainly because the final bits are usually different. That's a common pattern in float computations, numerical computations. But if you look at it, they're about the same results. You can basically embed a cat image or things like that as well. It gives you a lot of flexibility. Interesting, that image is not showing up, probably because of network issues. But the embedding result is basically exactly the same. The good thing is basically once you write a class, you can run things or debug things locally, and you can use Ray, existing Ray infrastructure, to run all those kind of things remotely as well. Right? Now, if I want to deploy things, it's kind of similar as well. RayServe has a way to basically offload, or basically like to reroute ingress to a fast API application, which is the underlying server that we use for Lepton AI as well. So you basically say, you write an adapter, you instantiate that clip class, and then you ask RayServe to reroute all those traffic into that application that we use. Right? I'm probably going to be running out of time, so I'm not going to be diving too deep into the code, but let's run that. And then we can basically say rayserve.run. It binds to a service address. In this case, it's local. And we will basically just call it using kind of like HTTP requests and things like that. Right? So it gives you the Ray version, and kind of similar, it gives you the local results, and it gives you the remote results. Now, remember, we just talked about the fact that Lepton AI gives you quite a lot of different models to very easily pull up. Let's say, like if you want to create a model called, where's the model string? Oh yeah, so you basically create a generic Ray adapter that that takes in a model string and then instantiate that model. Now, for the sake of speed, I'm still going to be using HFGPT2, but you can plug in Llama 2 and you request a GPU, and it runs the same as well. RayServe pulls up that service, and then when you basically try to call it, it takes some time, and also mainly because it's going to be downloading the Hugging Face models and things like that. Let's wait for half a minute. Once it starts up, then you will be able to just call it similar to the way you call every kind of single ray-serving function and things like that. You can also use clients that gives you interesting documentations and things like that to continue keeping in a Pythonic environment for your development and stuff like that. So you can just call it as if it were a Python function, and you get exactly the same result that you will be getting with the HTTP services and things like that. Now, imagine this is a very simple GPT-2 kind of model for the lack of time. Imagine if you can basically use the same number of lines of code to pull up Llama, to pull up all kinds of your favorite models on Hugging Face. That would hopefully be much more convenient for you to run applications with all those AI models that are out there. Okay, so let's come back to the conclusions, because I'm probably running out of time. We really want to create an open source kind of solution for us to allow us access to production-ready models with minimal code, right? We want things to be Pythonic. We want you to not worry too much about infrastructure pieces and things like that, and you will be able to just enjoy the plethora of open source models out there. We, of course, do a bunch of optimizations and things like that, so you can kind of stay assured that the launch models are high performance, high throughput, and things like that. If you're a Ray user already, then using Lepton AI is as simple as adding one dependency in your Ray environment. The thing we really love about Ray is that it gives you a very simple, again, Pythonic way to define what kind of software packages, Python packages that you need, right? So you basically do runtime environment, add in one dependency over there, you initialize the Ray environment, and you'll be able to run all those kind of models with ease. On the left, well, actually on the right, these are a bunch of kind of demos that we kind of pulled up with QR code generations, code llama, and things like that. If you go to lepton.ai homepage, you'll be able to check that out. There's also a Whisper model and things like that, just for fun. And our goal isn't really to basically provide APIs. Our goal is basically to help you to get access to those kind of models as easy as possible. So the whole code base is open. We are going to be putting up the Ray integration examples as well. For our platform, we're in beta, just a shameless advertisement. So if you're interested in basically using a serverless platform that runs AI models and things like that, feel free to contact us. That's our homepage, and then we're in contact. We'll help you to run AI more easily. Thank you.
Great. I think we have time for just one question. If anyone has a...
Yes, sir.
Thank you for the talk. So you demoed two ways of basically building RPC services, right? One is using the Lepton AI itself and the Photon thing. The other is using RayServe. So can you give some guidance, like when should one use A versus B?
Right, yeah. So basically, they are kind of complementary in the sense that when you write a Photon class, it really enables you to basically do local debugging and things like that really easily, right? You can basically just run it in process as if it were just like Python class, or you can basically invoke a launch function that I didn't show, and it gives you a local HTTP service. Now the question then becomes, how do I actually put it remote, right? How do I put it on a GPU server and things like that? Which is basically where Ray Remote comes in, or RayServe comes in. Ray basically says, I'll take that class, and I'll ship the code onto a remote machine on that cluster. And then you'll be able to just like call that thing remotely. Now, under the hood, well, in our platform, we basically like provide those kind of capabilities in a serverless way. But like if you are basically having a Ray cluster, and that kind of resource orchestration becomes really easy. And also, there's the difference between Ray Remote and RayServe. Right. I think remote is really good for like batch compute and things like that, and serve is, if you want to put things online for others call into and things like that, that's serve. So.
Cool. Well, thank you so much.
All right, thanks so much.